Scholars, the purpose of this video is to review some of the factoring techniques. Let's start with the greatest common factor. As an example, if we are interested in factoring 4x plus 12, this polynomial in general, which is a binomial, what we do is we attempt to find we factor each term. Here, baby steps. So we have 4x. Of course, I can break down 4x as 2 times 2 times x. 12, we can break it down as 2 times 2 is already 4 times 3, 12. And what's common between these? Of course, we have the 2 and the 2. So 2 times 2 will be 4. So our greatest common factor will be 4. Therefore, my binomial, if I were to factor out the 4, we leave x, the first term, plus 3 from the second term. If we factor this, it will be x plus 3. While we master this, we should always verify multiplying back. 4 times x, 4x, 4 times 3, 12. Allow, we are done. Let's try another example, very similar to that one. What about if I have 7a plus 7? Of course, our greatest common factor is 7. This is 7 times a. This is 7 times 1. So greatest factor 7. If I pull out the 7, we get a plus 1. We are done. What about 10x minus 10? Once again, what is our common factor? This is 10 times x, 10 times 1. We may factor out the 10. So we leave x minus 1. What if we have something as follows? 4y squared plus 24y plus 28. Okay, here, of course, is 4 times 1. Let's always try this here. Let's try the 4. So, of course, to the 4, this is divisible by 4. 4 times 6 and 28. 4 times 7. Notice that I have here y to the second, y to the 1, but I don't have any y. The third term, therefore, I cannot factor out the y. The only thing that is common would be the 4. And that's what we proceed to factor. We factor out the 4. And I have 1 times y squared plus 6y plus, say, everything plus 7. And we are done. We should always multiply back to make sure we factor correctly. Let's try one more. 5x cubed minus 25x squared. Of course, we have 5 times 1, 5 times 5. We have x cubed, x squared. Every time we're looking for the greatest common factor, if we combine, if we share variables, we share the exponent, the lowest exponent. In this case, between 2 and 3, x squared will be the x with the lower exponent. Notice that 5 is the common factor. And in terms of the x cubed, x squared, so we can factor out 2 x's. So what do I leave behind here? Remember, 5 is 5 times x times x times x. This here will be 5 times 5, 2 x's. So we factor out 1 of the 5 and 2 of the x's. 5 and 2 of the x's. So here we leave behind x minus 5. And we're done. Few more examples. What if we have 21x cubed, 9x squared plus 15x? This, of course, the x is common. This is x to the 3, x to the 1, x to the 2, x to the 1. Of course, always the lowest exponent, so it will be x with the common factor. It seems that also 3 is common. 21 is 3 times 7. 9 is 3 times 3. 15, 3 times 5. So we can factor out the 3 plus 1x, right? So let's see what we have. If we factor out the 3x, we leave 7x squared minus. We are factoring out 3x from 9x squared, so 9 divided by 3, that will be 3, x to the 1. If I factor out the 3, on the 15, that'll be 5. The 3, the x on the x will be 1, so it'll be plus 5. This example, it seems that perhaps 3 is the, in terms of the numbers, the coefficient, it's 3 times 3, 3 times 2, 3 times 7. So yes, 3 is a common factor. Notice that I have x to the 1, x squared, but I don't have x on the third term. So x is not part of the greatest common factor. However, I have y squared, y to the 3. So we choose the lowest exponent, in this case, y squared. So what is common? The 3y squared. So if I were to quote unquote divide by 3y squared, so 9 divided by 3, that would be 3x, and y squared by y squared. Okay, that's it. In this one, if I were to factor out the 3, 6 divided by 3, that would be negative minus 2. X squared, we have to go, we didn't factor any, and we factor y squared. That would be minus x squared. Plus, we factor the 3, so we still have the 7. We have y to the 3. We factor out y squared, so I still have 1y. That would be it. In the example, notice that we have here 8 and 24. 8, of course, is 4 times 2, 24, 6 times 4. So notice that 4 is also the, no, I'll take that back, sorry. 8 is 8 times 1, 24 is 8 times 3. So 8 will be the greatest common factor. 4 was a factor, but not the greatest. Notice that we can factor out the 8. However, since the lead term is negative, we should always factor out the negative. So what do I have? Negative 8 parentheses. So we only have here x. Now we factor negative, so this is positive, becomes now negative 3. If we were to multiply back, negative 8 times x, negative 8x, negative 8 times negative 3, positive 24. And this is very similar. 64 is 16 times 4. To know that 16 is also the greatest common factor. However, lead coefficient is negative, so we factor out the negative as well. So negative 16, if I were to factor negative 16 from here, we only leave the x. And if I factor out 16 from here, then I leave, what am I leaving here? Plus 4. Okay, careful with those signs. Negative 16 times x minus 16x. Negative 16 times 4 minus 64. Another technique for factoring is factor by grouping. We use grouping when no common factor, we cannot find any factor among all the terms. And normally grouping we use it when we have 4 or more terms. That's when it really makes sense, but we'll see what we have. So if we don't have any common factor among every term, all terms, we then divide and conquer. Perhaps we can try to divide in two groups of 2 and see what happens. ignoring the last two terms, what's common between 8b and 7b? It seems that b is what is common, so we can proceed to factor the b from the first two terms. So we leave behind a plus 7. And ignoring the first two terms, what can we factor between the third and fourth term? 8 times 8, 56 is 7. 8 times 7, of course, we can factor out positive 8. If I put the 8 from here, we leave the a plus 7. And notice here that we have a common factor x, 8 plus 7. As a whole term, we can factor out a plus 7. So what do I leave behind here? B. If I factor this here, would be 8. And we are done. So let's do a couple of those, very similar folks. Yeah, this is 3. It's a very small 3. Okay, so let's go ahead and factor out practically with the next example. Xy, 3y. Is that 3y is a common factor. So y, so we have x plus 3. 2 times x, 2 times 3 is 6. Of course, we can factor out the 2. So I leave the x. 6 divided by 2 will be plus 3. And now x plus 3 is the common factor. So we have plus 3 times y plus 2. Let me write it down here. X plus 3. So we leave behind the y and the 2. And we're done. This was 72, I believe. I erased it with my hands here. So we'll try here. M squared plus 6m. We may factor out the m. So we leave m plus 6. 12 times 1, 12 times, 12 times 6, 22, yeah. We can factor out the 12, however, since the lead term is negative, factor out the negative as well. So factor out negative 12, that will be here m, negative 7 here, that will be positive, that will be plus 6. And now, of course, m plus 6 is the common factor. We leave here m minus 12. Last but not least, between b squared, that would be b minus 5. B times b squared, b times negative 5, negative 5b. What is common here? 4, but the lead term is negative, so let's go ahead and factor out minus 4. So we leave here b minus 5. Negative 4 times b, negative 4b, negative 4 times negative 5, positive 20. Okay, so notice now that b minus 5 is the greatest factor. So we factor out completely as one term, b minus 5. Now we leave behind b minus 4.